Hello folks, well I thought it was going to be another set from the gentleman with the farming and trucking business in Leicestershire, but it isn't. We're doing one of these. It's an Amstrad 901 and it's a Hong Kong 901. So is it the £59.99 Hong Kong one, or is it the £29.99 one? We're going to find out. It comes with Amstrad branded microphone. It comes with the power lead, which we can now support. So these are being made for us, these 3D printed plugs with commercial pins and screwed together properly. Mr. Chippie's making these up, and these fit, but they don't fit like the other ones did, because the originals, which are shown here, have got these locking things which snap off. So the person doing the 3D printing, they don't need to have that, and that's what he's doing. So we can do those. I don't think they're on our eBay thing because it's virtually a special order item. So he's only been doing those for the last few months for us, and before we've been having to convert them to the normal square round type. So it's not so much a performance difference with these, that the squelch is the letdown if it's the fake one. Amstrad 901 Hong Kong 717853. You see, in Alan Sugar's book, he says there's only one batch of Amstrad CB radios from Japan, so I don't understand it. Are all the Hong Kong ones fake? You know, he said there was only ever one shipment. So if there were 2 shipments or 3 shipments and they got cheaper and nastier every time, he'd surely have said so. We'll use our standard test mic. If you remember, we faffed about with that yesterday. Brand new mic, 2 dry joints in the plug. Customer says he's already tried it, so we're not going to worry about powering it up slowly or anything. Power supply on 13.8 volts, and I haven't connected it to the power supply. Noisy volume control. Right, let's go into picture in picture. 3-watt scale. See what we've got. Well, it's beyond 3 watts. It is 3.4. Mind you, probably haven't got the inadequate resistors in the ballast dropper circuit on the transmitter on the fake one. .4 channel 40, 3.1 channel 1, 3.1. That's weird, isn't it? Well balanced though. Back to channel 40. Power consumption 1.276. Low power. Is 220 milliwatts. Deviation on this test set while is 5. Frequency, we're still warming up on this test set, so it might show low. 2779114 is virtually spot on. Will be when it warms up. So with that, we'll put that into the signal generator. 2779114. Go away, thin lead. That'll do. So we'll look at this into our test gear. Right, let's have a look at the SINAD meter. .58. I better check RF gains up. No, it's not. Well, that's made a difference. 0.21. 0.2. Yeah, if you want sensitivity, you need one of these chassis sets. Not necessarily the Hong Kong one. It's the same chassis as the set we did yesterday, the NATO 40. Squelch. Is it going to work? So, I like it to be 100 microvolts for the squelch to come in on full. 3, 10, 30 is coming in at. Yeah, this might be as good as it gets. It's coming in at 9 microvolts on full. See what minimum is. .3. So that's good, but the other one isn't. So our S meter for 100 microvolts is reading plus 30, which is wrong. It is set for 33, which is too generous. On transmit, when you press transmit, how many watts do we get on the thingy? We're on low power, aren't we? Let's try again. We're reading all of the bars, which isn't right. So it's full scale deflection. Potentiometers we've covered. Let's check public address. So we'll plug into the other socket. Public address. Testing 1 2, testing 1 2, testing 1 2 1 2. That works, apart from the noisy volume control. I'll check the Roger bleep into our walkie-talkie. Could have sworn I switched it back to CB, but I hadn't. Roger bleep on. That works. Channel 9 works. So, very good receive, nearly spot on frequency, doing 3.4 watts. So, usual thing, I need this set to do 3.5 watts for me to pass it. Otherwise we'll change the ballast resistor for a heftier one, but usually the fake version is better than the real one in that respect. Let's see if we can do anything better with the squelch, but that's the letdown. So here's the thing, before we go any further. When I open this up, if the printed circuit board is screen printed with the component locations, here's a scrap Japanese chassis. You've got all the part numbers on this side. The Amstrad part number sticker is meaningless because it can be faked, can't it? If the part numbers are on here, I think it's just a cheap version of the real thing. But Alan Sugar never says that. If it hasn't got the part numbers and it's a bare board, have we got anything with a bare board to show you? But you know what I mean? Absolutely blank, no writing on this side of the board. Then it's the El Cheapo fake, the $29.99 one. So the real one was $89.99. The Hong Kong better version is $59.99. And then the El Cheapo version was $29.99. And until we go inside, we can't tell what version of the Hong Kong one it is. Well, it is the better version. Don't expect you get tags on this one. I don't know when we last saw this version. This is kind of the interim one. We don't see this. We either see, good grief, that's had some work. It's had a lot of work on the receiver. Looks to have had the audio chip changed. Anyway, we'll clean all that up. But it just isn't the quality. If we go bring back this genuine Japanese one, wiring's thinner. You know, it just isn't the quite quality. Good. Well, this customer, last time we saw the fake one, it was this customer's. His trucking business has quite a few. He has a trucking business in Norfolk, near Norwich. Okay, so we'll do the VCO. We'll go to channel 1. And it wants 2 volts. Far side of that capacitor, if we can get our prod onto it. Well, nobody's checked that in living memory, have they? .3 is a little bit high. I think we better put our crocodile clip on the earth because it's a floating chassis. if our other crocodile clip is connected to Earth, which it isn't. So we want to knock the coil to 2. And on transmit we want it also to be 2. 2.4, so we'll just hopefully drop that a fraction. .02 on transmit, 2.01ish on receive. Check on channel 40, somewhere around 3.5, 4 volts. It is on both, that's fine. So we've got 2 plus 2. I can't remember what it was. Was it? I think it was 2.5 plus 2.2. Doesn't matter, it's right now. Right, we'll see if we can tune up the transmitter. Been doing a Dynatron SRX30 chassis. Really posh radiogram for a neighbour. He's my neighbour, half a mile down the road, because I live in the middle of nowhere. And he's been asking me to do this for a couple of years. And it's something a late friend of his bought him. It's a really posh cabinet radiogram. Oh, it's got a built-in tape recorder as well. And they were 600 and something pounds in 1974. What a lot of money. Anyway, I've done all the capacitors, switched it on for the first time, and we've got the right hand channel is down. Got a Duff transistor in that, which I don't have in stock, so we're having to wait. It's not one I'm showing because I can't show. I've just taken the chassis out because I can't really be bringing 600 weight of radiogram here. So he's only half a mile down the road. It's take it out there, put it back there. We'll do the turntable. It's a Lenco gold rings. It's really nice. Right, back to this. Got to find my peak, and it's there. And there. That second one was right. That third one wasn't right. Just check placements of some of these coils. They are crucial. I think we're at 3.6. And you know what? I've gone and done all that on channel 40. We'll just start again. Back to channel 20. I would think if I've got 3.6 on channel 20, I had 3.6 on channel 40. I think by the time that's cooled down, it'll be 3.7 or 3.8. So we'll come back to that. Let's put it on frequency. Where's it gone? Oh, of course it's that. There we go. Right, see what we can do with the receiver. Let's put the extension speaker back in. So we're on a single wire, as I've explained before, because it's a floating chassis. And so we'll need to connect an earth. Yes, you can see these aren't soldered, it's just bent over and hopefully clamps at some point, but it's not doing it. Over to the oscilloscope. And we'll do the detector once this trace comes up. A bit more volume. Not quite right. Now, that could mean we've got worse sensitivity when I finished than what we had when we started, because that wasn't right. If people tune up a radio without test equipment, just talking to their mate, you can end up with the detector very wrong. So it wasn't very wrong, but it certainly wasn't right. So we'll do the front end now using the SINAD meter. Pop the squelch down. About 6 dB. Improvement there. That one was spot on already. That was spot on. See if I can see these on the SINAD meter at this level. Yep. I'm going to look at the S meter as well with these. Just take the S meter sensitivity up. So I'm looking at now the oscilloscope, the SINAD meter and the front panel meter to make sure I'm on the right peak. We've actually gained some there. There we are, we're done. So let's see whether it's worse. I say it can't be better, can it? It's so... Ugh. It's just, if I could put 0.205 down, I would, but it's not. It's 0.21. It's that little tiny bit better. It's less than 0.2, but if we change ranges, I've got a. It's not going to make any difference, I don't think. Yeah, it still says it's 0.2, so we're in that bit in between. So we'll put that down as 0.2. But it's probably 0.195. 20 dB. Now this should be better if that's possible. 0.43. It's 0.44. So there we go. We've got the correct detector, and we've got minutely better sensitivity. You'll get another 1-inch range. Now this will have affected the squelch. I'll tell you what, we'll do the S meter next. That was being a bit generous, wasn't it? Let's make it less generous. So we want it to be S9, just not quite on the plus 30. So now as I increase the signal, nothing happens. Okay. Well, I've just got it glowing. Yeah. Right, well, I can see why they've misset that, because it never glows ever if you don't misset it. So we've now got the S meter reading it was 33 before, it's 37, so it's still too generous. I've left the meter on. Right, the power meter. Let's go back to transmit power. Turn the volume down a bit. Let's see what we've now got. I mean, it's still warm. It's only been 5 minutes since, isn't it? I'm going to say 3.8 on channel 20. I'm going to say 3.7 on channel 40. 3.8 on channel 1. Current consumption back to channel 20 is now 1.351. So it's gone up a little tiny bit. It's gone up 50 milliamps or something for another half watt. And what's happened to low power? Is it worse? Is it better? Who knows? Well, it's now 280 milliwatts. It's a little bit better. Squelch. So, can we set this anything better? Let's put it on full, see what happens. So we'll go over to the attenuator. So I'd like this on full squelch to be 100 microvolts when it comes in. So 1, 3, 10, 30, 100. Well, it never ever comes in, which is useless. So we've got to kind of come up with some compromise. So with that 100, I'll tell you what, I'll put 300 on the signal generator, and we'll adjust this till it comes in on the preset, which is there. Can we just get it a bit finer than that? No, we can't. I'm not going to dare to touch that. But have we lost anything at the sensitive end? Turn the signal generator to standby. Because you can end up with these sets doing absolutely nothing. So you've got no receive hiss, even with the squelch fully down. It is coming in at 0.3, so we've got the sensitivity still, and we have gained a bit at the top. So we'll take it to full squelch. So 1, 3, 10, 30 is in. It's coming in at 20, 28. So it's still as weak as dishwater, but it's blooming sight better than 9. So there we go. That's that done. So that's the letdown. Yeah, the tolerance of the components just isn't quite there. But they're not totally different in performance than the real thing. We need to clean this volume control. Luckily it's the type you can. That's fine. Everything else is alright. We've done that. Did we ever set the meter? We didn't, did we? Fiddling with the power, taking the readings, not setting the meter. Are we on low power or something? Of course we are. So once it's just not quite on the plus 30. There we go. Just got the deviation to do. I suspect of being high. Just going to go on the test set behind me and put the right glasses on. Then I'll take a break. I think we're going to look at that region tone radiogram. I mean, I've started on it. I've started the part 1 video, run the chassis through the dishwasher. So we haven't taken anything apart of the one I bought the other day. What we're doing is putting the broken one together and sorting it out. The one which I bought, which had already been scrapped and was already in bits. So the idea is that if I get stuck as how things are connected together, I can look at the one we've bought, and then of course we can work on the one I bought. There we go. Let's see what it says. Wow. Yeah, at least 5. Wow. The only people who benefit from having deviation that high are people who are listening to you on a Fidelity 1000. So technically we're done and I'm taking a break. Right folks, well it's just now a matter of putting it back together. We'll take it off the test gear. Solder the speaker back on. Oh yes, and when I do this side I realise it's all got to be cleaned up. We'll take the power supply off. It is awful. Right, where's Mr. Chippie's toothbrush? Well, that's certainly going to work till it dries. Isopropyl alcohol, it needs doing. So does that bit of soldering there to the chassis. And while we're in the bottom, check these screws are tight. Yeah, well that looks an improvement. Sharper corners on these than the Japanese one. I think we'll start again with this. Get that one on right. Didn't say we could get any screws in there. It's a matter of getting all this to match up. easier if we took the mic out. Right, we'll get the aerial plugged in, the Solarcon 99, and we'll see whether the radio is dry enough to work. I'm going to switch it on in PA. We're going to start with the customer's mic, which I've already misplaced because it's up here. Testing 1 2. Testing 1 2. Testing 1 2. You know what? You have to plug a PA speaker in for that to work. Testing 1 2, testing 1 2 3 4 5. So that's with the customer's mic. Then we'll go to our mic. That's got more gain, hasn't it? Whoa. 1 2 3 4 5 5 4 3 2 1. Right. We're on the aerial. Let's see whether the set's dry enough to work. Well, no, Roger. Oh, there we go. We're doing on the air test. I think we're going to be using a vintage camcorder again because I've forgotten to bring the other camera back from the chapel. But at least I found the key. So there we are, 3.8 watts output. I've not filled in that, it was actually 5. 2.2 to 2.5 kilohertz. And the mic works and the internal speaker work. There we are, the Hong Kong version, but the more expensive Hong Kong version, and it seems to work alright. So thanks for watching. Amstrad 901. These are about 1982-83.